Hi math students, I'm Mr. Hajgassim and today we're going to learn how to factorize expressions using the difference of two squares. Now before we start, I just want you to pause the video and write the following numbers in index form. And what I mean by index form is so that you would write it in the form of, if I can just annotate, in the form of a to the power of b, for instance. Now, we can start with 1. 1's an interesting one because we can write 1 to the power of 1. We can also write 1 to the power of 2. We can also write 1 to the power of 3. We can write 1 to the power of 4. We can actually write 1 to the power of infinity because 1 to the power of any number will still give us 1. 1 times 1 times 1 times 1 times 1 times 1 will still be 1. So with 1, we can write it to the power of any number. Any number greater than 1, that would be. Although actually 1 to the power of 0 will still be 1. But let's not get too caught up on that. What about 25 then? 25 can be rewritten as, well, we've got to notice something here. 25 is a square number. So the square root of 25 will be 5. Therefore, 5 squared is equal to 25. So 25 written in index form will be 5 squared. Likewise with 64. 64 is quite an interesting one because it's a square number, but it's also a cube number as well. So 64, the square root of 64 is 8. So 8 squared is 64. We can also write 64 as, well, cube root of 64 is 4. So 4 cubed is equal to 64. So we can write 64 in index form as 8 squared or 4 cubed. 81 is a square number, and that's going to be 9 to the power of 2. 9 to the power of 2 is 81, so 81 written in index form is 9 squared, and 100 is also a square number, and we can rewrite 100 as 10 squared. That's really good and really desirable for you to be able to recognize square numbers and rewrite them in index form for this topic. Now, if I just clear the drawings, and we can move on. Now, the difference of two squares, so it's kind of in the name if we think about it. The difference, what does the difference mean? If we want the difference, it means we're subtracting two amounts, right? So the difference means subtracting, and a difference of two squares. So let's think about 64. What is 64? 64 is a square number, so that's almost as though we're saying 64 minus another square, which is 9, because 8 times 8 is a square with an area of 64, and 9 is a square with sides of length 3. Likewise here, we have 25, that is a square with an area of 25 with sides of length 5, minus 16, which is a square with side of length 4. So this is what we mean by the difference of two squares. Now, we can rewrite these as, and if I just clear my drawings, we can rewrite this as in index form. So I can rewrite this as, in fact, 64 minus 9 is 55. However, I can rewrite this as 8 squared minus 3 squared. And this can be rewritten as 8 plus 3 multiplied by 8 minus 3. Would this work? So let's think about this. 8 plus 3 is 11, and 8 minus 3 is 5. 11 times 5 is 55. So that gives us the answer here. Now you may be wondering, why am I taking all of these long steps when I can simply work out 64 minus 9 is 55? I'm just trying to see if we can spot a pattern here. Let's have a go at 25 take away 16. 25 take away 16 is going to be 9. Now we can rewrite this as 5 squared minus 4 squared, which can be rewritten as 5 plus 4 multiplied by 5 minus 4. 5 plus 4 is 9. 5 minus 4 is 1. 9 times 1 is simply 9, and that gives us the answer we had over here. So can we spot a pattern here? Well, the pattern is if we had any number in the form of a squared minus b squared, we can rewrite this as, or we can factorize this as a plus b multiplied by a minus b. And this is the difference of two squares. And this works because if we were to work backwards, if we were to expand this expression, we would get this expression here. And I will just expand to show you how that will work. So I'm just going to rub this out. And if we had a plus b multiplied by a minus b, what we'll have is a times a is a squared. A times minus b is minus ab. Then we will have b times a, which is positive ab. And then we will have b times minus b, which is minus b squared. Now minus ab plus ab will simply cancel out. That will give us 0. So what we'll end up with is a squared minus b squared. So a squared minus b squared is equal to a plus b in brackets multiplied by a minus b in brackets. And this is very useful when we're factorizing. So let's have a go at some questions. So if I just clear all of this, and we can move on to here. So I have x squared minus 25. Excuse me, I have x squared minus 25, and I need to factorize this. So how would I start by doing this? Now you might be tempted to say, well, 25 is a square number. So this is simply x minus 25 multiplied by x plus 25. Or you could write it the other way around, x plus 25, x minus 25. It doesn't really matter which way around you put your plus or minus sign. However, what we have to notice is that we need to rewrite this in the form of a squared minus b squared. So we have to write 25 in index form before we can apply this method of the difference of two squares. So firstly, we have one square here. That's going to be x squared. We'll have length of sides x and x. X times x gives us an area of x squared. And minus 25 is going to give us an area of 25 with length of sides 5. So we have to rewrite this as x squared minus 5 squared. So don't forget to write this number in index form. So what this will be is x plus 5 multiplied by x minus 5. And again, if we were to expand this, this is the expression that we will end up with. And I'm just going to expand just to double check I've done this right. So x times x is going to be x squared. X times minus 5 is going to be minus 5x. And then I will have 5 times x is going to be positive 5x. And 5 times minus 5 is going to be minus 25. So minus 5 plus 5x, well, these two cancel out. So what I'm left with is x squared minus 25, and that's the expression I started with. So x squared minus 25 is actually equal to, and if I just rub these out and use a different color pen, what I'll have is x plus 5x minus 5. Okay, so you can pause the video and have a go at this example. I'm just going to go through it now. So if I just clear all the drawings, what we'll have, and I will use blue, what we have is a squared minus 81. So again, remember that this 81 needs to be written in index form. So this is going to be a squared minus the square root of 81 is 9, so that's going to be minus 9 squared. And now, if we apply what we've learnt, this is going to be a plus 9 multiplied by a minus 9. And if you're unsure, you can expand this and see if you will get the expression that you started with, which is going to be a squared minus 81 for that matter. Okay, and moving on to some trickier examples. So quite often when you're asked to simplify algebraic fractions, you may have to recall this skill. So let's think about this problem. To simplify algebraic fractions, now I've done this before in another video, so if you're unsure about algebraic fractions, by all means do watch that video. However, what we need to do first is to factorize both expressions, so the expression on the numerator and the expression on the denominator. Now what you need to recognize is that this problem is a difference of two squares. I'm subtracting, and I also have two squares. So x squared is a square, or a square number we can say, and 4 is also a square number. So this will require you to factorize using the difference of two squares. And if we were to factorize this, what we'll have, or how we can rewrite it, is that x squared minus, we need to write this in index form. So minus 4 squared, and this is going to be x plus 2, x minus 2. So once we factorize this, we will have x plus 2 multiplied by x minus 2. And the reason why we factorize is so that we can cancel down any factors that are the same, or the highest common factors essentially. Now if I just rub all of this out, and then we can have a go at factorizing the expression on the top. Now this is a quadratic that can be factorized using the more traditional method that you learn. So what we need to think about is two numbers that add to give us 2, and the same two numbers that multiply to give us minus 8. So add to give us 2, multiply the same two numbers to get minus 8. Be aware of that sign, we need to include that minus 8. So the numbers are going to be, well, 2 and 4 give me 8, but they won't give me minus 8. So I can work with 2 and 4, and the difference between 2 and 4 is also 2. But one of these numbers has to be negative. Well, if I choose minus 2 times 4 is minus 8, and at the same time, minus 2 plus 4 will give me positive 2. So minus 2 and 4 work out. So once I've got these two numbers, I can rewrite this expression as x plus 4, x minus 2. Now I can start to cancel down. So I have an x minus 2 on the top, and I have an x minus 2 on the bottom. So they cancel out, and what I'll be left with is x plus 4 over x plus 2. And be aware, these x's do not cancel down because they're not factors. We're simply adding x to 4, and we're simply adding x to 2. And another way of thinking about this is if we give x a value, if we said x was, say, 6, so we would have, let's say, when x is equal to 6, in this case, we could have 6 plus 4 over 6 plus 2. Well, this will be 10 over 8, which is going to be 5/4. However, if you were to cancel the x's down, in other words, cancel out the 6's, you would have 4 over 2. But this expression is not equal to 4 over 2, 4 over 2 being 2. So just be mindful, when we're adding a term to the numerator or the denominator, we can't just cancel them out. All right, so let's do another example. If I just clear all the drawings. So moving on. Now we have x squared plus 4x minus 21 over x squared minus 9. Again, have a look at this problem and think to yourself, do I have the difference? Yes. So this is the difference. I'm subtracting. Do I have square numbers? Well, 9 is a square number, and x squared is a square. So this problem is the difference of two squares. And then to deal with this, we have to rewrite this in index form. So this is going to be x squared minus 3 squared. X squared minus 3 squared is the same as x squared minus 9. So now I can rewrite this as x plus 3, x minus 3. So this is the factorized version of this expression here. So we will have x plus 3, x minus 3. Now we need to factorize the numerator. So again, I need to think of two numbers that add to give me 4, and the same two numbers that multiply to give me minus 21. Notice this negative sign belongs to the 21, so minus 21. Now, two numbers that multiply to give 21 and have a difference of 4, well, that's going to be 7 and 3. So 7 and 3 have a difference of 4, but I need a negative number. Now let's think about this. If 3 is negative, well, 7 times minus 3 is minus 21, and 7 plus minus 3 is going to be 4. So these two numbers satisfy the conditions that we're looking for. So to factorize this expression, we'll have x plus 7 multiplied by x minus 3. Once again, we need to cancel down the factors. So x minus 3 and x minus 3 are factors. Therefore, what we'll end up with is x plus 7 over x plus 3. Once again, don't get tempted to cancel these x's out. We are simply adding them to the numerator and the denominator. The x's are not factors. They're only factors if we were multiplying. So if we had x times 7 over x times 3, well, in this case, x is a factor of 7 and x is a factor of 3. And we can then cancel them down, leaving us with 7 over 3. But over here, x and x are not factors of 7 and 3. Right, I hope you found this useful. Just to recap, the difference of two squares is where we're subtracting two square numbers away from each other. It's usually written in the form of a squared minus b squared is equal to a plus b, a minus b. And then typical questions will be something like this, where you have a variable that's squared or raised to the power of 2 minus a square number such as, let's say, 100. Then what you will need to do is recognize that this is the difference of two squares, rewrite both terms in index form. So x squared is already in index form. 100 written in index form will be 10 squared, and then we can rewrite this in the form of x plus 10 multiplied by x minus 10. And this is very useful when you're simplifying algebraic fractions. Right, boys and girls, I hope you found this useful. Thank you very much and have a good day.